this lesson we'll learn how to multiply and divide rational expressions. To multiply rational expressions, we're supposed to first factor completely every numerator and denominator, and then when everything is factored already, reduce common factors. So those are the two things to remember: factor and reduce. Here we have some examples. Let's do the first one. We need to multiply these two expressions. Except for numbers that are not fully factored, the rest of the expression is factored completely. And we don't have to worry about numbers too much because we know how to reduce, for example, 6 with 3 or 10 with 5. So we don't need to rewrite 10 as 2 times 5. We already know that 10 is divisible by 5. So we are ready to reduce everything. Remember, you can reduce any factor from the numerator with any factor from the denominator. It doesn't have to be reduced across or within the same fraction. Any common factor from either numerator can be reduced with the same common factor from either of the denominators. So let's try. 10 reduced with 5, leaving us 2 in the numerator and 1 in the denominator. We don't need to write this extra 1 here because we want to keep our cancellation as clean as possible, and if we start reducing a lot and writing a lot, it starts to be messy. So we don't need to write 1 because 1 doesn't change the answer. Multiplying by 1 is like doing nothing. Okay, what else can we reduce? 6 with 3, leaving us again 2 in the numerator. And then we can reduce x's. For example, I see one x here and some x's either in this fraction or in that fraction. It doesn't matter which one you reduce with. For example, we could reduce this x with that x. And again, the answer would be 1 here and 1 there. The 1 doesn't have to be written. Okay, finally, we can reduce this y square with 2y's hidden in the y cube. So we are not crossing the entire y cube, we are crossing just the 3, leaving with 1y still there. But then we have this y, and this y can be reduced with the remaining y, so all y's are really gone. Okay, so what's left? In the denominator there's nothing, so we won't have a fraction anymore, we'll have just a numerator. In the numerator we have 2 times 2, which is 4, and we have x squared. Everything else is gone. So we've done this multiplication. Let's see the second example. Again, let's start with reducing numbers. 7 goes with 7. 3 cancels this 3. And negative 6 and 2 we can reduce by 2. So in the numerator we still have negative 3 left over. Now, we see a lot of letters, a lot of A's and B's and C's. So we could cancel everything, but sometimes when you cross so much, it's hard to see what's really left over. So we can reduce in steps. We can reduce, for example, the most obvious factors that we see. I see b squared here and b squared there, so they will be gone. 1c here and 1c there. And I see b cubed here and b cubed over there. They will be gone. Okay, why don't we rewrite what we still have? Even though this expression is not reduced fully, I think it's better to rewrite everything nice and clean. So negative 3, and then put together all the powers of the same bases in the numerator. So we have a squared and a cubed, all together a to the 5. And then we have c to the 4. In the denominator, we don't have any numbers. Now there's 1a here and 1a there, so it's a squared. And there is 1b and 1c. Okay, and try to reduce again. For example, I see a squared and a to the 5, so I can reduce a squared with 2 a's out of those a to the 5, so I cross just the 5, replacing it with 2. And I can reduce 1c with 1c from the numerator, so instead of 4, I end up with 3 more c's in the numerator. Okay, now I can finish this example. The numerator is negative 3, a squared c cubed, and in the denominator we still have b. That's the final answer. Let's see the next example. Here we have a polynomial multiplied by a rational expression. Remember that this polynomial can be seen as a rational expression just by dividing it by 1. So the polynomial is really a numerator. Okay, do we have everything in a factored form? Well, except for these numerical factors, the rest is in a factored form, so we are ready to reduce. We could reduce this whole bracket x minus 2 with the x minus 2 in the numerator, and we could reduce the 13 with 26, leaving 2 in the denominator. And that's all what we can do here. So the final answer is the numerator is just x plus 2, and the denominator is 2. So as you see, multiplication of rational expressions, it's not really difficult because we really just reduce common factors and whatever is left, that's the answer. Okay, let's look at the last example. This time the expressions in numerators and denominators, they are not really factored. So the first step to do is to factor everything that we can. The first expression, prepare two brackets. What do we have here? The product 3 and the difference 2. Okay, so we have to have m, and two numbers that multiply to 3 and differ by 2. It will be 3 and 1. The difference is negative, so the 3 will be with negative sign and the 1 with positive to make the overall product negative 3. Okay, what do we have in this numerator? You can probably recognize the pattern. That's a difference of squares. So we prepare two brackets, one with plus, the other with minus, and we use the square root of the expression that we see here. So it's m, square root of 4 is 2, and 2. Everything over. And how do we factor this denominator? Oh, we have a common factor 2. Take it out. What's left is m plus 2. And over there, again, prepare two brackets. Similarly as before, the product is 2, the sum is 3, so it must be m plus 2 and m plus 1. Product 2 and sum 3. Okay, now we are ready to reduce any common factors that we see. So for example, m plus 2 goes with m plus 2, m plus 1 cancels this m plus 1, and the rest has to stay. So final answer is m minus 3 times m minus 2 over 2 times m plus 2. And there is no need to multiply those brackets. It's better to leave the answer in a factored form. So that's all what we should do here. How do we divide rational expressions? Well, similarly as with fractions, we don't like to divide by fractions. So what we do, we change division into multiplication. But since we change the operation, there must be some consequence. We multiply by the reciprocal of the divisor, exactly the same as when we divide regular fractions. So after we change the division into multiplication by reciprocal, we just follow the strategy of multiplying rational expressions, which means we need to factor and reduce like on the previous page. So here's the rule. To divide by a fraction a over b, we multiply by the fraction that is reciprocal of a over b, which is b over a. Let's see some examples. Okay, in the first example, let's rewrite the first rational expression. And instead of this division, we are writing multiplication, but then we change the divisor, the second fraction, into reciprocal. So y goes up and xy squared goes down. So that's important to remember. We are flipping the second fraction, never the first, just the second one. The first fraction stays the same. Okay, as soon as we have a multiplication problem, we use our reduction strategy. So we reduce y with this y, and x times x is really x squared, so these two x's will cancel the x squared. Okay, let's cancel these two x's together with the x squared. And finally, this y cancels one y from the bottom, so instead of exponent 2, the exponent will be really 1. Okay, we can rewrite what we end up with. In the numerator, there's nothing. But what's nothing for multiplication? It's 1. And this 1 is essential. You can't skip it. You can't overlook this because it will change the meaning of the fraction. Okay, in the denominator, we have 3. And a single y from the second fraction. So it's 1 over 3y. And this 1 is essential to write. Some students write just 3y, and obviously that's not the same as 1 over 3y. Okay, let's look at the second example. Here we need to factor everything in the numerator and denominator, and also we need to change this division into multiplication by the reciprocal of the divisor. So let's concentrate on the first fraction, factor everything completely. In the numerator we see difference of squares, so it's a minus 2 and a plus 2. The denominator, we can pull the common factor, which is 3, out of the bracket, so we are left with a plus 2, and then change the division into multiplication by the reciprocal. That means the a plus 2 goes up and a minus 2 stays down. Now we are ready to cancel common factors, so a plus 2 can be cancelled either with this bracket or with that bracket, it doesn't really matter. Let's cancel it with that one. And a minus 2, this is like in a bracket, it will be cancelled with this bracket. Okay, so what's left? In the numerator we have just a plus 2. In the denominator we have only 3. A lot simpler expression. Let's look at the next example. This time we have two operations in a row, but remember, order of operations, we go from the left to the right when we deal with multiplication or division. So first we need to multiply these and then divide. We can rewrite everything in one step by changing this division into multiplication by the reciprocal of the last fraction. So let's combine these two numerators. That will be 3, and there's y squared and y cubed, so it's y to the 5, over 3 times 4 times y. We can write this in a factored form. We don't need to multiply. 3 times 4 times y. Okay, now we need to change division into multiplication by the reciprocal. So in the numerator we have 20, in the denominator 15. Okay, now we are ready to reduce. We can reduce the 3's. We can divide 20 by 4, leaving us 5. And then this 5 can be still reduced with 15. So let's reduce 5 with 15. This is 1, so I don't need to write. And here is 3. Okay, is there anything else that I can reduce? Yes, it is the y. Y will be reduced with the 5 y's in the top, making the 5 equal to 4. So the final answer, in the numerator, I have only y to the 4. In the denominator, I have 3. So the final expression is y to the 4 over 3. And finally, a little bit bigger expression. Still, we need to watch the order of operation from the left to the right. So first we perform this division, which means we are going to replace this division by multiplication by the reciprocal of the very next fraction. In the meantime, we are going to factor every single numerator and denominator if possible. So the first numerator is a difference of squares, x minus y and x plus y. In the denominator, we have common factor x cubed that can be pulled out. So inside the bracket we have still left x minus 1. And then instead of this division we write multiplication by the reciprocal of this fraction. So it's x squared over x minus y. The next operation, which is this multiplication, stays as it was. There is no change here. And then x plus y, it's already in a factored form. However, the denominator, it's not. I hope that you can recognize that this is a perfect square formula. This factors into x plus y squared. Okay, now we're ready to reduce whatever is possible. For example, this x squared can be reduced with the 2x's, leaving 1x still in the denominator. Now x minus y could be reduced with this x minus y. And in the numerator we have two brackets. Each of them is x plus y. So these two brackets will cancel the square of x plus y, because those are also two brackets of x plus y. Okay, what's left? In the numerator, as you see, there's absolutely nothing. So nothing for multiplication means 1. And we need to keep this 1. In the denominator, we have this x and that bracket. So it's x times x minus 1. Final answer. Okay, so now you try to practice more questions from the textbook.